Assalamualaikum and a very good day to everyone. In this video, our group will be presenting about maximum and minimum problems. Now let's meet our group members.
Hi, my name is Iskandar.
My name is Muhammad Shamizan.
Hello, I'm Yasir and I hope you guys will enjoy our video. So what is applied maximum and minimum? Optimization is the process of finding maximum and minimum values in calculus. Many application problems in calculus revolve around finding the external points of functions, whether they are maximum or minimum values. Next, why do we solve maximum and minimum problems? Shahmizan, can you explain why?
Sure thing, sir. By solving maximum and minimum problems, we can enhance comprehension of the application of differentiation. It is important to grasp the concept of applied maximum and minimum problem. This understanding enables us to effectively solve problems by employing the appropriate formulas and techniques.
Well done, Shahmizan. Next, how do we solve maximum and minimum problems? Can you explain this for me, Iskandar?
I can, sir. First, we have to find the derivative. Next, we have to let the derivative equal to 0 and find the values of the variables. Finally, we have to do a second derivative test. If second derivative is larger than 0, it is minimum value. If second derivative is less than 0, it is maximum value.
Thank you, Iskandar. Now, let's proceed on to the questions. A closed cylindrical container of radius rcm and height hcm is to be made to hold 600 cm3 of liquid. A. Show that the surface of the area of the container is 2 pi r² plus 1200 over r. B. Find the values of r and h that minimize the total surface area of the container. Answer in 2 decimal format. C. Hence, find the minimum surface area of the container. Now, Shahmizan will do question A and Iskandar will do question B.
For question A, we must show that the surface area of the container is 2 pi r² plus 1200 over r. The equation for area of cylinder is 2 pi r² plus 2 pi r h. Given the volume of cylinder is equal to 600, we must use the volume formula of cylinder, which is pi r² h, and move aside the pi r² to the right side, giving us the value of h. After that, we must substitute the h into the area of cylinder equation to finally get 2 pi r² plus 1200 over r.
The first step for question B is to find the derivative. We must use the equation from the previous question, which is 2 pi r² plus 1200 over r. After that, we have to differentiate the equation to get 4 pi r minus 1200 over r². Step 2. Let the derivative equal to 0, which gives us 4 pi r minus 1200 over r² equal to 0. After that, 4 pi r equal 1200 over r², then multiply 4 pi r by r², which gives us 4 pi r cubed equals to 1200. Next, move the 4 pi to the right, giving us r cubed equals to 1200 over 4 pi, giving us the chance to use cube root for 1200 over 4 pi to cancel out the cube for r. In result, r equal to 4.57 centimeters.
I think you forgot to do the final step, Iskandar, which is to do a second derivative test. Doing this will give us 4 pi plus 2400 over r cubed. When r equals to 4.57, we then substitute the r into the second derivative, which result in 4 pi plus 2400 over 4.57 cubed. This brings us 37.71, which is bigger than 0. So r equals to 4.57 cm is a minimum value. We then substitute r into h, which we received from question A earlier. That results in h equals to 600 over pi 4.57 square, resulting 9.14 cm. Finally, Shahmizan, can you give the answer for question C?
Yes, sir. To find the minimum surface of the container, you must substitute r equal to 5.57 into the cylinder formula, which is 2 pi r square plus 1200 over r. So the final answer is 393.81 centimeter square. So, the bell has rang!
Wait, from our lesson today, I hope you guys can correctly identify the relevant formula and accurately perform both the first and second derivatives, which will result in obtaining a reliable solution, whether it is a maximum or a minimum problem.